Hi everyone. Good morning, good afternoon, good evening to people from different parts of the world. Welcome everyone to Ortelius Visionaries 2022. My name is Utkarsh, and for the next 10 minutes, we'll be discussing few of the famous design patterns that might help you in designing your microservice-based applications. So let's start. Before moving further, let me give you a brief introduction about Ortelius open source project. So if you're developing microservice applications, so Ortelius is different. Ortelius is basically a microservice cataloging tool that not only cracks your different components, different microservices, but also consolidate a lot of useful information like what version is deployed, what is the stable version, what is the bill of material that is used for a component, and if there are any vulnerabilities. So if you're interested, you can check out ortelius.io, and that has everything that you need. So as I already told, the agenda for next 10 minutes is looking at few of the famous design patterns that can ease your life. Few words about myself. I'm a software engineer at Cisco India. I like to create a lot of services uh, using different cloud platforms, let it be like Azure or GCP. And I also like to contribute to the open source community. I like collaborating and working with passionate developers. That is where I joined Ortelius. And if you're looking for the same, Ortelius is the best place for you. These are the content that we'll be looking at in the next 10 minutes. We'll see how we can migrate the monolith to a microservice-based architecture. For that, we'll look at decomposition patterns. To manage data in a distributed ecosystem, we'll look at few of the design patterns like Saga design patterns, CQRS design pattern. And apart from that, we'll look at few of the reliabilities standpoint as well. Okay, starting with decomposition. So since we already know there are huge chunk of application already built on monolith, and a lot of jobs are there where they asked you to migrate their application to uh, microservice based application. So like if you're asked to migrate or convert a monolith based application, or if not monolith based application, you're asked to convert a SOA architecture based application. So how would what will be your thought process? So what we can do, we can either decompose our application based on the business capability that it has, or what we can do, we can um, decompose our application based on the subdomains. So just to add little more details, so decomposition by business capabilities means identifying the different layers of your applications that are responsible for different requirement, different that has a different business capabilities. So let's suppose there is a product, and there is a component that has the concern for that component is product development, while there is other component which only take care of like service or product delivery, and there is other component which concerns with demand generation. So what we can do, we can isolate this component and create a standalone microservice, and yeah, and they can talk to each other and solve that solves our purpose. While when we decompose by subdomain, so there is a famous uh, architecture which is called domain driven design. So we use domain driven design to create our microservices. So that has uh, you need a lot of understanding of the product itself, because you have to identify like which components you can um, uh, you know uh, segregate into one component. And so let me show you some figures. Okay, so as you can see, decompose by business capabilities. So it is fairly straightforward. So in most of the cases I have seen in the application itself, they have a layered kind of architecture. So they will have like a work management, user management, tenant management, and data management layers. But that is developed as a monolith or SOA. So what we can do, we can identify those and we can isolate them and create a different service, standalone service, and deploy them as a microservice. Um, while in decompose by subdomain, we have to identify like if this service, if this API would go into product catalog service, or that service should reside in delivery service or something. So these kind of challenges are there. So that takes like a lot of to and fro meetings with different folks to identify that. Apart from that, there are few of the other design patterns that we see nowadays. So nowadays, what we see, um, so we identify like what all services can be, self-contained into one service. So that is one design pattern that we can use. The other one is if you are creating your application from scratch. So I've seen like a lot of people, they create a different team as per services. So there will be one team that will be only concerned with the data, we call them as a data team. There will be other team which will be taking responsibilities of all the applications that are related to machine learning and algorithms. Coming to data management. So what is the problem that we want to solve here? So in microservices, there will be distributed transactions. So how we can handle those distributed transactions so that there is consistency in the data. So there is a famous design pattern to solve this distributed transaction problem in microservice that is called Saga design pattern. And we can tweak this Saga design pattern in like whatever base suits you, but the overall the base architecture will be very similar to this. So first, there are like two approaches to Saga. One of them is choreography based approach. So in choreography based approach, your request will be propagated to the different services, and they will be again propagated in the reverse order. So let's say if you have like three services A, B, and C, and you make a call to service A, then the service A will do a call to B, and that B will call service of C, and then C will return something, and then B will return something based on the output that he has got from the C. So this kind of approach is called choreography based approach. So in that case, let's suppose at any point of time your service has failed, so the ultimate output would be field itself. So in that case, we maintain the data consistency. The second approach is orchestration based. So in that case, what we do, we create an orchestration layer that is responsible for orchestrating. So that will be orchestrating different threads. And let's suppose let's see this diagram. So uh, if you want to create an order, so what you need some customer information, you need payment information, or even you need like inventory information, like if the product is available or not. So there we have like orchestration which will post a event. So here we have used a message broker. So it is posting an event to uh, which will be consumed eventually by customer service, and customer service based on that event will return some other event to the other topic, which is a reply channel on the reply channel. And this create order module will uh, consume that event, and based on the event that he has consumed, um, he will identify if he has to create an order or not. So let's suppose there if he has got a success, from a customer. Okay, so at the later point of time, there will be another module that will be, so the orchestrator will again orchestrate a method to a different topic, which is, let's say, um, a payment module. And let's say at that time the payment got failed. So if the payment got failed, the eventually the uh, output would be the eventual, the ultimate response would be fail in that case. So this is how we uh, maintain the orchestration layer. And in some cases, we also create a additional layer which is called a state machine. So which has like uh, which maintains the state for every request. So every so let's say if you want to create a order, so order can have like that order can generate a different methods, different it can publish a different events to different applications. So there is a state machine which maintains a state for every other services, and the state machine will only um, you know um, publish a success event when the state machine itself gets success from all the event, consumes the event that has success from all other applications. Okay, so there is another design pattern that you can use alternatively to Saga design pattern, which is called CQRS. So what problem we are solving here in the CQRS is, let's suppose you want to you want to implement a query that retrieve data from multiple services. So we know like if there are 4 services and if you are making a 4 DB calls, that will be very much expensive, because if you are developing a large scale applications, that will be converted to thousand or millions. So millions requests means you are there is a cost involved to every DB call that you make. So what we can do, we can define a some kind of view database, which is like a read-only replica. So, but that is subscribed to the uh, database services, the other applications. So in that case, you only have to query that view database that you have created, and in that case, you decrease number of queries that you make to your applications. So this creating a view database is not a very I would say popular method, but similar kind of tweaks I've seen people make in their application, make in their product to reduce the DB calls. Okay, coming to the reliability perspective. So let's suppose you are writing a code. Okay, so what happens uh, if at some point the other service is not available, or let's say if there is a service A which has to publish an event to service B, and service B is not available. So at that point of time, what should be the flow of the execution? So that is already a known issue in microservice, but we implement the solution for the same. So what we do, we implement something called a circuit breaker. So breaker is nothing. So we define a flow in a program itself while developing. Um, so these are the scenarios when we consider when there is a when we identify like the other service is not available. So let's say if you want to publish an event, but the Kafka topic is not available. So what do you have to do? So you can implement a fallback method saying there is a different topic, let's say error topic. So you can push those events into those queues. Or let's say if you're not able to make connection, um, so service B is down, so you're not able to consume services that are written in B backend service. So in that case, you can write a fallback scenario that will return some generic response. So, and you can also maintain some kind of record for that. And you can process that afterwards. So in that case, whenever we identify there are some services which are not responding, so this circuit breaker, the implementation that we write uh, will be set on, and in that cases, whatever request it will receive in that point of time will be handled by a fallback scenario, the fallback method that you write. And after a certain point of time, let's say if you have defined some timeout for the circuit breaker, so after that uh, timeout, that circuit breaker will be off, and then again it will take a few requests and see if your application is able to consume the services of the other. If not, then it will again go to the on state, and all the requests will be handled by fallback. There is this Netflix histories that you can see if you want to implement this kind of patterns. So if you have any question, let me know. There are like a lot of other design patterns. They are just a few. So if you're interested exploring more design patterns, microservices.io is the best place for you. So as I already told, if you're interested knowing more about Ortelius, you can visit ortelius.io. If you're interested exploring the code base, so all the code base of Ortelius resides in github.com/Ortelius. You can also follow Ortelius for different topics like that are related to microservice and DevOps. So on LinkedIn, you can go and search for Ortelius open source, and I believe you should find that. And apart from that, if you're interested connecting with me, you can follow me on Twitter, LinkedIn, and GitHub. The handle is the same, that is Code with Utkarsh. That's all for today. See you. Have a good day. Bye-bye.